And this video is just a quick instructional of how to graph inequalities in two variables. You may have already learned how to graph them in one variable on a number line, but in two variables we just have to remember that we're going to use both x and y, which means instead of just pointing in one direction, we're actually going to do some shading. And instead of using open or closed circles, we'll use solid versus dashed lines. So if you do not have an equal sign, that means that all of the points that are normally on your equation no longer actually work in the inequality. They're the ending points. So we'll use a dashed line to represent, similar to an open circle, the fact that that's where your shaded area stops, but the points on the line don't actually count. Whereas with a normal equation, all the points on the line make the equation true. So when we do have an equal sign, such as less than or equal to, or greater than or equal to, all of the points on the line are included, or they actually count. So we use a nice solid line to represent the fact that they work within the inequality. Shading is there to represent, again, which points above or below that line actually count in the inequality. And one great way to figure out which way to shade is to check any point that's not originally on the line, either dashed or solid, so that you'll know whether or not the points on that side of the line are true. Therefore, all points on that side can be shaded in as solid points, or if all those points on that side of the line are false. Thus, all the points on the other side of the line can be shaded in as being true. So let's try a few examples real quick. A fairly simple graph to make would be y equals 2x. So if we imagine that inequality just to be an equal sign, we could just graph the points, well, y-intercept being 0 with a slope of 2. So I'm going to go up 2, right 1, up 2, right 1, or down 2, left 1 on there. But now before I draw my solid line, I need to represent the fact that the original equation or inequality did not have an equal sign. It's not an equation. So instead of drawing a solid line, we're going to draw a nice dashed line through all of those red points to represent the border. Now I just need to know, do I shade to the left or above my dashed line, or to the right or below that dashed line? Now some people say that since y is less than, we would know that, well, if y travels up and down, I want all the points less than that border. And that is one great way to figure out that you're going to shade below the line. As long as you're solved for y, all of the points that have a y value less than my line, my 2x, should be solid points. A great way to double check that is to pick any point in that shaded region, such as 2, 0, and I'm going to plug it into my inequality. So if y were 0, when x were 2, well, is 0 less than 4? Since that's a true statement, I'm going to shade toward that point. Again, if I checked any point on the other side, it would have come up false, and I would have shaded again to the right or below my red line. Let's do the same thing over here. Remember, an x equals equation is a vertical line. So since I want to graph x equals 6, I better count by 2s. Let's go ahead and label this 10. And I'm going to count by 2s and say that this is the vertical line at x equals 6. And since there is an equal sign on here, I can do a nice solid line right there. I also then want to say that x needs to be less than or equal to. So I could use any point less than that line. And as far as x is concerned, x travels left and right. To go less than, we travel to the left, which means I can shade in any points to the left of my line. And again, you could check a point. 0, 0 is in my shaded region here. If x were 0, again, there's no y to plug in for, but is 0 less than 6? Since that's true, I would shade toward that red dot. Again, if I picked a blue point that was to the right of, such as 10, 0, well, 10 is less than or equal to 6 is a false statement. So I would shade away from, notice the blue point is not in the shaded region, or the feasible region as it's often called, of all the answers. Go ahead, solve for y on this one on the lower left, and also graph the one on the lower right, and see if you don't come up with the right answers. I'm going to pause the video now, and give it a few seconds, and I will put up the answers. Alright, I went and solved the equation on the left for y. graph the slope of 2/5, but starting with a y-intercept at -2. Again, a solid line because there was an or equal sign there. And then I picked the point 0, 0 at the origin because that's often the easiest point to plug in when it's not on your line. And I found out that that was a false point. So I knew that since 0, 0 was above the red line, I could shade below. Again, and a great idea to look at is that y is less than the equation of our line. And so I would be shading as y goes downwards, y being less than my line. It's another great way to figure that out. Over here, same idea. You're already in y equals mx plus b. So I started at -3, slope of -1/4. Plugged in the point 0, 0, found out it was false again, and shaded below my red line. Again, the only graph up here that you need to be really careful of before you drew your line was the one in the upper left. Notice, again, no equal sign. It meant a dashed line for the border. But then other than that, it just comes up to shading. Now, you can do this same idea with many other graphs, such as an absolute value graph that we learned how to graph just one section ago. So, first thing I want to figure out is where is my absolute value v shape going to be? And you notice that again, from this +2 and -3, I would have a vertex of -2, -3. So let's start our graph there at -2, -3. Then I'm going to notice that I have a -1 slope going out to the right. So that -1 in front means my v shape is going to be pointed downwards. Also notice I can make a nice solid line because I'm less than or equal to on my graph. Then the final thing to figure out is which way should I shade? Again, one great way to do that is to pick the point 0, 0. Notice it's not on my v shape. So I'm going to plug in 0, 0 into my equation. So if the output were 0, given that I inputted 0, notice 0 would be less than or equal to. Well, 0 plus 2 is 2. Absolute value of 2 is still 2. But then I put on that -2. So is 0 less than or equal to -5? Well, since that's a false statement, that blue area is not going to be shaded in. And I'm going to shade again. If that blue point is on the top of my V, I need to shade everywhere inside of my V. And there you go. I hope that helps you with graphing inequalities. Good luck, and have a great day.